Hello guys, I am Nidhi Bagalwadi, your science teacher Sankalp Learning Solutions. In the last class, we learned regarding the concept of electricity. We just started the concept of electricity and we learned various terms related to the electricity like charges, time, number of charges, charge of 1 coulomb, that all. Today we are going to discuss in detail regarding how the electricity is formed inside the conductors. So what are these conductors? The things or the substances which allow electric current to pass through them are called as conductors. So how actually the flow of charges occur inside the conductor and how actually the electric current is formed, that we are going to study in detail and in depth in this session. Suppose I said you the conductors are the substances which allow electric current through them or which allow flow of charges through them. The best examples of conductors we can give as metals. The best examples of conductors we can give as metals. Okay. So why metals are considered as a best example? We know that electric current is nothing but the flow of charges or the flow of electrons. So flow of electrons means when an electron has to flow, it should be free. So the free electrons, where we will find free electrons? The free electrons are the characteristic feature of the metals. As metals will be having free electrons, they are considered as a good conductors of electricity. Simply they are not considered as a conductors. They are considered as good conductors because they have the free electrons which move and which flow. That is why the electric current is produced. Suppose let us take a daily used metal as a conductor, that is a copper. So we know the symbol of copper, it is Cu, and its atomic number is 29. When its atomic number is 29, I can say that the number of electrons as well as the number of protons, okay, number of protons means positive charges, number of electrons means negative charges. So both are equal to 29. When we come to the electronic configuration, that is distribution of electrons in the shells of the copper, so we will get to know the electronic configuration will be 2, 8, 8 plus 2, 10, then 18, 26, sorry, 8 plus 28, then 1. So at last you can see in the last shell we have only one free electron. We have one free electron. Means that electron is not bounded. It is free. The valence electron is how much? The last shell. What is valence electron? The electron which is present in the last shell or the valence shell. So that valence electron is free now. Right? That valence electron is free. This is a valence electron. Now let us consider a conductor of a copper. So let us see the atomic structure. There will be protons and neutrons, and surrounding the shells will be surrounding the nucleon, that is protons and neutrons. So here electrons will be moving, right? And in the last shell we have one electron. So let us consider a wire of a copper which have many atoms. A wire is a conductor. Copper wire is a conductor of electric current, right? So let us consider a wire of a copper which has many atoms of copper. So as I said, proton, neutron, proton, neutron, proton, neutron, forming the nucleus, and electrons will be revolving in the shell. So at last shell, that is in the last shell of an atom, we have one electron which is free. We have one electron which is free, this one. So this one is a valence electron, this one is a valence electron, this one is a valence electron, and this one is a valence electron. Okay. Now what happens actually? When we supply external energy, this electron is there, no? This electron will be revolving around the nucleus. So this electron will not keep quiet. It wants to jump to this shell. It wants to jump to the shell of the second atom, of the atom which is beside it. So how it jumps? It will not jump simply. It will jump until we provide external energy. So when an external energy is supplied, so that makes this electron to jump. Why it will not jump simply? Because it will be attracted towards the nucleus by the electrostatic force, right? So when we provide the energy more than the electrostatic force, then the electron jumps. So what happens when it jumps? This electron come here. Okay. This electron comes here. And again, when the energy supply continues, again these two electrons jumps here. So this jumping of electron by the external energy, by providing external energy continues. So what happens? There will be a continuous movement. That is, there will be a continuous jumping of electron from one shell of atom to the other shell of atom. So this jumping movement, this continuous movement causes flow of charges. So what is this flow of charges? This flow of charges is nothing but the current, or we can say electricity. So this flow of charges forms or produces certain force. So that force is nothing but the current or the electricity. So this is how the jumping of the electron, the continuous movement of an electron produces a kind of force which is called as electricity or a current in the conductor. This is regarding how the electric current will be formed inside the conductor. Right. Now, let us study about the circuit. Okay. So, what is this circuit is? From lower classes we learned regarding the circuit. What is this? The circuit is nothing but a closed path. It is a closed path of flow of charges. So let us understand this definition. Let us understand this definition in detail by drawing a circuit diagram. So let us consider a battery. So a battery is denoted by this symbol, a battery. It is nothing but a number of shells forms a battery. Okay. So this is a battery. And now the battery is connected to a bulb. Okay, this is a bulb. And here we have the ammeter, so which measures the quantity of a current, with the device which measures the quantity of the current, right? Then this one. So from the negative terminal, this is a negative terminal. The small line indicates negative terminal, the bigger line indicates positive terminal. So from the negative terminal, the flow of electrons begins. So when the flow of electrons, here we will be having the switch. Okay, this is a switch. When the switch is on, so this symbol indicate the symbol, the bracket with a dot indicates switch is on. Okay, switch is on. So when a switch is on, the flow of electrons will be there. So the electrons will start to move from this direction. Okay, from this direction, that is from negative terminal to positive terminal. Okay, so this flow of electrons produces electric current where the bulb glows. So this is what the bulb glows when the switch is on. Now the bulb is glowing. The bulb glows. Okay, this is a representation of a bulb. Now what happens when the switch is on? The electron path or the flow of electron is continuous. When the switch is off, what happens then? When the switch is off, the flow of electrons will not be continuous because here we have some gap, right? So here we have some gap. the flow of electron is not continuous. When the flow of electron is not continuous, the electric current will not be produced. Right? So when the switch is off, we can say open circuit. Why? Because the circuit is not completed here. The flow of electron is not complete. When a switch is on, we can say it is a closed circuit. Okay. So this closed path of flow of charges is called as circuit. This is regarding the definition of circuit, and this is closed circuit and open circuit. This is a representation of switch on. Okay. And this is a battery. This is ammeter. Okay. And this is the bulb. And these are the condition when switch is on and when switch is off. This is how we can represent a circuit. And when we come to the direction of current, okay. So when we come to the direction of current, you can tell me that the direction of current is from negative to positive. From negative terminal to positive as of the circuit diagram and as of the practical. That is, the flow of electrons will be from negative terminal to positive. But our older scientists, okay, based on their discovery, they predicted or they said that the flow of electricity or the electric current will be from positive to negative. We know the correct thing is negative to positive is a correct thing. But our older scientists predicted or discovered that the direction of electric current will always from the positive to negative. So till now we are following this direction only. Till now we are following that the electric current flows from positive to negative. So we are using this conventionally. I repeat, we are using this conventionally, but the correct path is it flows from negative to positive. Okay, due to our older scientist discovery, we have to take it conventionally as it is flowing from positive to negative. Okay, so this is regarding the flow of electrons inside the conductor and the brief note on the short circuit. That is, the brief note on the circuit and the types of circuit, that is closed circuit as well as open circuit. Okay, now let us consider a problem in our NCERT textbook. The problem goes like this actually. They asked us calculate number of electrons in 1 coulomb of charge. Okay. Now, so here let us consider what is given first. Okay. We know that the charge of one electron will be equal to 1.6 into 10 raised to minus 18 coulomb. This is the standard charge of electron. This we should be knowing. Okay. Now, they have given the charge as 1 coulomb, and what we have to find? We have to find the number of electrons. Okay. We have to find the number of electrons. So, we have two methods here. First, we will consider a formula, that is charge is equal to number of electrons into charge of an electron. Charge, this is a charge. Okay, Q is a charge, is equal to, this is number of electrons into charge of one electron. Okay, then so let us substitute. We want n, right? So what happens here? N will be equal to Q divided by electron. So Q is 1 divided by 1.6 into 10 raised to minus 18. Okay, 1 coulomb. This is also coulomb. Coulomb get cancelled. Then 1 by 1.6 we will get as 0.625. When you calculate, you will get 0.625 into 10 raised to minus 18. When it comes up, it becomes 10 raised to 18. So when we solve this, when I take this decimal point this side, so what happens there? 6.25 into, okay, 6.25 into, sorry, it is minus 19 coulomb. It is 19. Here also I should write this as 90. Okay. 6.25 into 10 raised to minus 1 into 10 raised to 19. So I will get the answer as 6.25 into 10 raised to 18. 6.25 into 10 raised to 18. So I can say in 1 coulomb of charge we will be having how many electrons? 6.25 into 10 raised to 18 electrons. Okay. 10 raised to 18 electron. This is one method. One more method is simply by cross multiplication. So here 1 electron charge is equal to 1.6 into 10 raised to minus 19 coulomb. Okay. Then here it is 1 coulomb, and here we should ask or we should find how many electrons. This is 1 electron. So when you cross multiply, it will come like this. 1 divided by 1 electron into 1 coulomb divided by 1.6 into 10 raised to minus 19 coulomb. Coulomb get cancel. 1 into 1 is 1. So again it comes 1 by 1.6 into 10 raised to minus 19. When we solve it, we will get same 6.25 into 10 raised to 18 electrons. Okay. So 1 coulomb of charge contains 6.25 into 10 raised to 18 electrons. This is regarding a small problem in the NCERT textbook. In the upcoming sessions, we will move to the more numericals as well as the more concept regarding the electricity. Until that, stay safe. Have a nice day.